So it's all about quadratic equations. Now we are going to study about quadratic equations, and particularly we are interested in finding out what is meant by discriminant and nature of roots. Okay. Good morning everyone, my name is Lokesh. Today we'll discuss about quadratic equations. Now let us say the general format of a quadratic equation is ax square plus bx plus c is equal to 0. Now we have to find out discriminant. One second. Yeah. One second. Now I'll just write the formula for discriminant. Discriminant is denoted by d, that is equal to b square minus 4ac, that is equal to b square minus 4ac. Now where this is used, the main intention of the finding out discriminant value is by seeing the discriminant value we can say the nature of the roots, whether the roots are positive, whether the roots are negative, imaginary, or roots are equal to 0. So all we can say by finding simply the discriminant. Okay. Now for example let's take an example, 6x square minus 7x plus 3. Let us say this is an example, or this is a quadratic equation. Now we have to compare it with general format of like ax square plus bx plus c is equal to 0. That means a is equal to 6 and b is equal to minus 7 and c is equal to 3. Now we have to find discriminant. Discriminant d is equal to b square minus 4ac. That means b is here minus 7, right? Minus 7 whole square minus 4 into a means here 6, right? 6 into c means here 3. So minus 7 whole square is 49 minus 4 6 are 24. 24 3 is 72. So 49 minus 72. It will be 3 minus 23. It will be minus 23, right? 52, 62, 72. Yeah, it will be minus 23, right? So like that. So for a given equation we can find the discriminant value. Now I'll just tell the applications of this discriminant. Yeah, see here. I'll just highlight the points. Yeah. Now if discriminant is greater than 0, for example, if discriminant is greater than 0, then the roots are real and distinct. Then the roots are real and distinct means different. So if the discriminant value is greater than 0, then the nature of roots is real. Real numbers means we can say minus 2, 2, 1, 0, okay, like that, 3, 4, 5, 6. Okay, all we can say all these types of roots are real roots and distinct means different roots. Okay, and if d is equal to 0, they are real and equal, means we will get both roots same roots, like 2 comma 2, 3 comma 3, 1 comma 1, like that. Okay, and if discriminant is less than 0, we will get imaginary or complex number. This is one type of interesting topic. Have whole subject on the complex numbers. Okay, so when it will come when discriminant is less than 0. Okay, I'm repeating once again. If the discriminant value, what is discriminant value? B square minus 4ac. B square minus 4ac is greater than 0. Like that means d greater than 0. Then the nature of roots are real and different. Means two roots are different. If one root is 1, other root may be minus 2. If one root is 2, other root may be 3. If one root is 4, other root may be minus 6, like that. Okay, like that. So if d is greater than 0, then the roots are real and distinct means different. Real and different. And if d is equal to 0, that means b square minus 4ac is equal to 0. If b square minus 4ac is equal to 0, then the roots are real and equal. The roots are real and equal. And if d less than 0, then the roots are complex. That means imaginary. We can say imaginary roots or complex roots. Okay, so that's one kind of thing. So okay, you have to remember this thing. By finding out just the value of discriminant, we can say the nature of roots. Okay, Now we'll move on to next topic. Yeah, yeah. See here, when d is positive, that means d means a discriminant. When discriminant is greater than 0, the equation will have two real roots and distinct roots, right? We know that. This means the graph of the equation will intersect the x-axis at two different points. The graph of the equation will intersect the x-axis at exactly two different points. This is very important. Two different points. So that's what I'm telling here. Two real and distinct mean different roots. So the graph of this equation will cut the x-axis at two different points. Okay. Now there is a direct formula for finding out finding out roots from discriminant, and I'll write it now. Okay. I'll write it now once again. Yeah. Okay. Now if the equation is of this type, ax square plus bx plus c, then we can find roots by direct formula, that is x is equal to minus b plus or minus root of b square minus 4ac divided by 2a, and the value inside the bracket, inside the square root, and the value inside the square root is nothing but we are finding now as discriminant. Okay, I'm repeating once again. For a general format of quadratic equation, ax square plus bx plus c is equal to 0. For a general format of quadratic equation, ax square plus bx plus c is equal to 0. The roots are x is equal to minus b plus or minus root of b square minus 4ac by 2a. Okay. Now this is a case when d is positive. That means when b square minus 4ac is greater than 0, then the roots are real and different, and the graph of x-axis and the graph of equation will cut the x-axis at two different points. Like means we'll get the graph like this. We'll get the graph, for example, we'll get the graph like this. Okay, we'll get the graph like this, and yeah, it cuts the x-axis at two different points. Okay, once again drawing like this. We'll get the graph like this. Here one point, here one point. We'll get the x-axis at two different points, and we'll get two different roots. Okay, not same like that. We can also get roots equation like this, graph like this. Okay, it will cut the x-axis at two different points. It may be positive x-axis or negative x-axis. Now we'll just do an example. X square plus 5x plus 6 is equal to 0. Now we'll check the roots. Discriminant. We'll check the discriminant. Yeah, d is equal to b here. We'll compare with ax square plus bx plus c, and here a is equal to 1, b is equal to 5, c is equal to 6. Now b, what is b here? 5 square minus 4 into a means 1 and c means 6. So that means 25 minus 24. Therefore d is equal to 1. D is equal to d greater than 0. See, d greater than 0. D greater than 0 means the roots are real and different. And the graph will cut the x-axis at two different points, either like this or like this. Now we'll check it. See here, x square plus 5x plus 6, we can write as 2x plus 3x plus 6, right? And x into x plus 2 plus 3 into x plus 2, right? That means x plus 3 into x plus 2, that means x is equal to minus 3, x is equal to minus 2. There we are getting two different real roots, where it is cutting the x-axis means at minus 2, 0 and minus 3, 0. Like, yeah, this is the equation, minus 2, 0 and minus 3, 0. Okay, so this is the equation, one of the very important equation, right? D is equal to b square minus 4ac. So by just finding out the discriminant, we can say the type of roots, whether it is positive roots or it is negative roots or it is real and different or imaginary. We can just say, okay, that's our main importance of finding out discriminants. Now this is a case, one second, Now this is the case when d is equal to 0, that means discriminant is equal to 0, that means b square minus 4ac is equal to 0. Then we have two real and equal roots, that means the graph of x-axis, the graph of equation will cut x-axis only one point. That means graph will look like this, it will touch the x-axis at only one point, like this, yes, okay, like this, yeah. And the roots are given by x is equal to minus b by 2a. Two roots are given by x is equal to minus b by 2a. Why? The general format of the roots is minus b plus or minus root of b square minus 4ac by 2a, right? But this whole term is becoming 0, so that's why it will become minus b by 2a, other root also minus b by 2a. So we are getting two same roots, minus b by 2a, minus b by 2a. When will you get two same roots? When discriminant is 0, when discriminant is equal to 0, then only we will get two real and equal roots, So that's very important, two real and equal roots, right? So this is very important step. And the graph of equation will cut x-axis at only one point, right? Like this, 1 point. Now we'll just take an example and do it. X square plus x plus 1. We'll compare with general format, ax square plus bx plus c, and here a is equal to 1, b is equal to 1, and c is equal to 1. We'll just find discriminant d is equal to b. B means 1 square minus 4 into 1, 1. I don't think it will become 0, right? Once again, now take this example, 4x square plus 12x plus 9. Here compare with general format, ax square plus bx plus c. A is equal to 4, b is equal to 12, c is equal to 9. Now just find the discriminant. D is equal to b square, 12 square minus 4 into a, c 9. Okay, so the value become 12 square is 144 minus 4 4s are 16, 16 9s are 144. Now discriminant is becoming 0. Okay, discriminant is becoming 0. Now what we know, when discriminant becomes 0, the roots are real and equal roots. Now we'll check for this equation. We'll check 4x square plus 12x plus 9. We can apply direct formula, x is equal to minus b by 2a. Okay, minus 12 by 2 into 4. Now 2 1s are 2 6s are 2 3s are 2 2s are, so x is equal to minus 3 by 2. So both roots are this, or you can verify it by splitting middle term. So the product you should get as 36, and the sum you should get as 12. I think 6 and 6, we can get 6 and 6, right? 6x plus 6x plus 9. 6 plus 6 will give 12, and 6 into 6 will give 36. Now from the first two terms we'll take 2x common. You'll get here 2x plus 3, here 3 common, and you'll get here 3 into 2x plus 3. Now we'll just take 2x plus 3, again 2x plus 3, right? That's what we get. 2x plus 3 is equal to 0, 2x is equal to minus 3, and x is equal to minus 3 by 2. Even the other root also we are getting, x is equal to minus 3 by 2. Yeah, so from this we can understand that if discriminant is equal to 0, then the roots are going to be equal and real. The roots are going to be equal and real. Real roots and equal. Okay, now we'll just move on to last topic. Now we'll just see this example. When d is less than 0, that means d is negative. That means when b square minus 4ac is less than 0, we'll get imaginary roots or complex roots. The equation will have no real roots. We will not get any real roots. We will get complex roots. We will get imaginary roots. Okay, So that for example, root of -2, root of -3, which are not defined as real roots. These are all complex roots. Okay, these are all imaginary roots. So when this type of roots will come, when discriminant is less than 0, when discriminant is less than 0, this type of roots will come. Okay, and the graph of equation will not intersect x-axis. Mean the graph will pass some like this or like this, or somewhere. I mean some other equation like yes, this it may cut y-axis, but it will not cut x-axis like that. Okay, so this is when this d is less than 0. Now we'll just take an example for this. Yeah, x square plus x plus 1, and a is 1, b is 1, c is 1. Now we'll just find this d value. D is equal to b square minus 4ac. 1 square is 1, minus 4 ones are 4, and d is equal to -3. D is equal to -3, which is negative, which is less than 0. D is less than 0. For d less than 0, we will get imaginary roots. We'll get imaginary roots. Now we'll check what type of root we'll get. We'll check. Yeah, x squared plus x plus 1 is equal to 0. Clearly we understood that we will not get real roots. Now we cannot do factorization by splitting middle term, because splitting middle term can be done only for real roots. Splitting middle term factorization by splitting middle term. Factorization by splitting middle term can be done only for real roots. Only for real roots. That means only for d greater than 0 or d is equal to 0. For d less than 0, use direct formula. This is very important. This is very important step. This is very important. For d less than 0, use direct formula. Now see here. First of all, compare with general equation. Ax squared plus bx plus c is equal to 0. Now write what is a and what is b and what is c. A is equal to 1, b is equal to 1, c is equal to 1. Now find d value. D is equal to b square we already find this score. Okay, d value. Okay, now we should use a direct formula for finding roots. X is equal to minus b plus r minus root of b square minus 4ac by 2a. X is equal to minus of b value. B is 1, right? Plus or minus root of b square minus 4ac value, whole term. I think this value we already find here, right? B square minus 4ac. What we are getting? -3. Yeah, -3 by 2 into 1. That means we are getting -1 plus or minus root of -3 by 2, which is not a real root. Because root of -3 will not exist in real numbers, in reality. Okay, will not exist in reality. That's why we cannot find roots. Okay, we cannot find roots. Okay, so this is the topic. We'll just overview the topic what we have discussed, right? Yeah, discriminant means b square minus 4ac. Discriminant means b square minus 4ac. For any given quadratic equation, we can find discriminant. Okay, for any equation we can find d value, b square minus 4ac. Okay, so we just need to compare with the general format like this, and we have to write a value, b value, c value clearly, and we have to know we should not confuse between plus and minus. After writing a value, b value, c value, we have to just apply them in the formula. D is equal to b square minus 4ac. Substitute respective values of b, a and c in the formula of d is equal to b square minus 4ac. Once we get d, if d is greater than 0, yeah, see here once again, yeah, once d is greater than 0, we'll get real and different roots like 1 and -2, 2 and 3. We'll get different roots, not same roots, different roots like 4, 6, 4, 5, 2, 5, 3, 2, 1, 2, like that. Okay, when d is greater than 0, we'll get real and different roots. When d is equal to 0, we'll get real and equal roots like 2, 2, 1, 1, -3, -3, -3, -2, -2, 1, 1, like that. When d is equal to 0, we'll get real and equal roots. And when d less than 0, we are not at all going to get real roots. We are getting complex roots or imaginary roots when d is less than 0. That's very important, right? And one more point here, when d is greater than 0, we are getting real and different roots, and particularly if D is a perfect square, we'll get rational roots, and if not a perfect square, we'll get irrational roots like root 2, root 3, like that. Okay, if D is not a perfect square, we'll get irrational roots, right? Means root of b square minus 4ac. If root of b square minus 4ac, if root 16 will get 4, or else root 9 will get 3. If not root 5, so root 5 is irrational, right? So that's what we are discussing here, right? Then yeah, if D is positive, we'll get the graph like this. Means the equation will have two real and different roots, and the graph of equation will cut x-axis at two different points like this. We'll cut x-axis at two different points, right? When D is greater than 0, we'll have two different roots. That means two real and different. That's why the equation is cutting x-axis at two different points. Okay, and the roots are found by direct formula. X is equal to minus b plus or minus root of b square minus 4ac by 2a. This is direct formula for finding roots. Okay, please remember this formula. This is an example. X square plus 5x plus 6 is equal to 1. So here we are getting D greater than 0, and see here we are getting roots as yeah, we are getting roots some 3 comma 2, right? Minus 3 comma minus 2, right? Okay, then when D is equal to 0, we are getting equal roots. Yeah, when D is equal to 0, we are getting equal roots. So we'll check it. Yeah, we are getting both roots as minus 3 by 2, minus 3 by 2. When D is equal to 0, it will cut x-axis at only one point. It will cut x-axis at only one point. And one more equation is when D is negative. So when D is negative, it will never going to be cut x-axis and will not get real roots. Will get complex or imaginary roots. The example is this thing: x square plus x plus 1, a is equal to 1, b is equal to 1, c is equal to 1. Here d value we are getting as minus 3. So if D is less than 0, we'll get imaginary or complex roots. Okay, imaginary or complex roots like this. Okay, root of minus 3 is not exist in reality, right? So like that. Okay, now thanks for learning, and please subscribe, and if any doubts you have, please contact me in the given address in the description. Okay, we'll just stop here.